Jason, would you like to just give us a brief overview of what you plan to do, and then we can get your presentation going?
Sure, thanks, Stephen. Yeah, I think you summed it up pretty well there. We've launched a pretty big piece of work in the last week or so. So the idea today is really just to give you a snapshot, a high-level overview. We've only got 20 minutes, so I'll just be touching on some of the key outputs in terms of some of the positive messages for the transition that we have ahead of us, but also some of the challenges we face and where kind of technology and innovation fits within that sphere. So I just plan on touching on some of the key highlights and having a bit of Q&A at the end, and we have a more detailed session planned for next week, so hopefully many of you can join for that one as possible.
That's super. Well, thanks, Jason. Get ready to rock and roll with your presentation. Folks, please do collate your questions, put them in the Q&A function, and looking forward to a really good debate and question session at the end. So Jason, it's Tech20, you have 20 minutes to present this. Over to you to start now. Thank you.
Thanks, Stephen. So hi, everyone. Thanks for taking time out your day to join me today for this presentation. Hopefully some of you have managed to read or at least skim through the report we published last week. My plan today, as I mentioned, is just to give you a taster of the report, go through some of the high-level results, and just talk a little bit more about our ongoing collaboration with the ORE Catapult and the wide group of stakeholders that helped us kind of build and collate this report. Before I get into the actual presentation and the content, I've got a video that I wanted to share with you, which just summarizes the report in a nice, neat kind of visual fashion.
The UK's offshore energy sector faces a fundamental challenge: how to build on the technological achievements and advances of the last 50 years and use our energy experience and world-leading position in wind to drive nationwide economic prosperity and deliver an affordable net zero energy system by 2050. We need an integrated energy vision for the North Sea. A vision of a shared future with highly skilled jobs and opportunities for diversification, which builds on the UK's strong technical foundation. OGTC and the Offshore Renewable Energy Catapult have developed 3 scenarios to reimagine our energy system and identify where we need to accelerate investment and drive technology innovation at pace. Emerging sees an increasing role for renewable electricity alongside gas, which would remain a significant part of the energy mix. In Progressive, the electricity market becomes dominated by offshore renewables, together with a growing blue and green hydrogen split. And Transformational creates an energy system driven by offshore wind and green hydrogen, with remaining oil and gas demand matched by clean domestic supply. Each scenario delivers net zero. Each scenario presents different opportunities and delivers differing benefits for the UK, different costs, and different rewards. We must aim high. We must decide if we want to lead or follow. By 2050, pursuing a transformational scenario with investment of £416 billion could create 230,000 jobs, generate £125 billion for the economy, and unlock valuable global export opportunities. These integrated energy vision scenarios are designed to spark action and drive alignment between industry, governments, and regulators. We must invest in innovation at pace to build an affordable energy future, to create and protect jobs, deliver a net zero energy system, and unlock huge export potential. We must invest now to reimagine our energy future. Read the report from OGTC and the Offshore Renewable Energy Catapult to discover how we can create a net zero energy system.
So, a few numbers flying up on the screen there, but before I get into those, I wanted to give you a brief overview of the rationale behind the IEV, the Integrated Energy Vision project, why we embarked on the work in what is already a very busy landscape in terms of, energy transition reports. on the screen, I've just got a few. It's really a snapshot, and it's a small percentage of the reports that went into the building of this piece of work. But it's just to kind of try and highlight the level of public and published material that relates to the offshore energy sector and the transition to net zero. And although each sector has produced work covering its own ambitions, putting forward their own cases for funding and their role in the transition, there really needed to be a more holistic view, an integrated vision of the offshore energy sector as a whole rather than in silos, and kind of highlighting how by working together the UK can deliver on our climate goals first and foremost, whilst maximising UK content, UK jobs, and securing benefit for the wider economy, as well as securing our kind of sustainable energy future and our energy security. So in January this year, before COVID and social distancing, we all came together as a group in Aberdeen, in our office on Queen's Road in our innovation hub. The group consisted of representatives from upstream and downstream oil and gas, the renewables sector, academia, trade unions, devolved in national governments, as well as a variety of other public and private sector organisations. A full list of which you can find in the acknowledgements section in the back of the report. Our aim was to align all of the very valid, very valuable sector-specific work that's been going on over the past few years and really put that into an integrated context. So clearly no mean feat when you consider the differing views and opinions that are kind of traditionally held close by each of those separate sectors in isolation. But I'm delighted to say that, you know, over the course of the past year, we've come on a bit of a journey as a group, working together, albeit remotely via webinar for the majority of the year, other than that first session in January, to develop a kind of common understanding of the barriers, opportunities for the energy transition. And really what we did as a group was we went back to basics. We started from an aligned understanding of the UK's energy resources. I don't have time in this presentation to go through all of those different elements, but I plan to do that next week in the session we have on Wednesday. So we started off with that baseline, getting everyone onto the kind of common understanding of where we are in terms of our natural resources in the UK, and that pertains to obviously oil and gas, but also our natural resources in terms of wind, wave and tidal and other renewable sources, as well as potential for things like hydrogen production and for carbon sequestration. So we've done all of that work through the lens of the Climate Change Committee's Further Ambition scenario. And we've used that as our kind of guiding framework. And the reason we've done that over any of the other very valid work, for example, the National Grid's future energy scenarios or any of the very kind of well-published work that's out there, is because the CCC are ultimately guiding government on the energy transition and the obviously drive for net zero. So we've used that further ambition scenario as our framework, and what we've tried to do really is look at the offshore element of that and kind of critically assess that and say, well, are there alternate pathways that we could take in terms of the North Sea, to use a kind of bucket term, and are there alternate pathways that we can see a greater benefit for the UK rather than, you know, just the one kind of high level outline that we have from the CCC? But we've used their guiding principles and all their key assumptions on demand and obviously end use of energy. So I won't go into the whole kind of energy system in detail. I've just picked one example for this kind of brief presentation that we have today. You know, I would quickly run out of time in my 20 minutes before I'd even get to the next slide. But I wanted to highlight one aspect of the challenge we face between now and 2050. And just to represent this, I've chosen electricity generation. Please remember, this is only one element of the net zero challenge. You know, obviously we've got a wider energy requirement for solid and liquid fuels, etc. And there's a whole load of kind of core assumptions onshore that, in terms of home heating, transport and different habits that go along with it. Fundamentally, this kind of simplified visualization that I've got here represents the jump needed between now and 2050, according to the CCC's demand scenario laid out in the further ambition scenario. So today we produce and consume, give or take, 300 terawatt hours of electricity in the UK. Most of this comes from gas-fired power stations. A commendable and increasing proportion comes from renewable power, with the remainder being made up of other low-carbon sources such as nuclear, hydro, and we still have a small proportion of coal, which is being phased out completely. And I think that's one of the kind of success stories about our decarbonisation over the past 10, 20 years, has been the reduction in coal-fired electricity generation. However, when we look at our projected electricity requirements for 2050, we're looking at more than a doubling of demand, up to 645 terawatt hours. So this takes into account things like, increased efficiencies, and really stems from the widespread electrification of things like heating, transport, and the increasing requirements, I guess, that come along with an increasingly digital age. Even interestingly, with the 75 gigawatts of offshore wind that the CCC have outlined, and other increases in onshore and other renewables, we're still looking at similar, if not slightly higher, requirement for natural gas for electricity generation, which of course will need to be combined with CCS to remove the emissions. And when you consider this in light of our kind of mature basin, our aging oil and gas sector, I guess, with dwindling supply, this begins to ring some alarm bells. We already import around about 40% of our hydrocarbons, which primarily made up of gas. So can we really afford to have this reliance doubled by 2050? Both from an energy security perspective, but also from an emissions offshoring perspective. I think some of the figures published in yesterday or the day before's OGUK economics report highlight 157% increase in LNG imports in the last year, most of them coming from the Middle East. And LNG is roughly double the kind of carbon footprint of our domestic oil and gas. So it just highlights some of the potential issues that we may face, between now and 2050 in terms of, one, offshoring the emissions, but also, energy security. So to consolidate and reinforce our findings from the IEV work, we've developed 3 different scenarios to highlight the challenges, but also the opportunities that face the UK on our kind of road over the next 30 years towards 2050 and towards net zero. We've developed them to kind of highlight different paths that are available to us. Ultimately, all of them achieve net zero, and they all are governed by the core assumptions and demand requirements laid out in that further ambition scenario. But each of them has, as you'll see, quite a different outcome in terms of UK energy security, jobs, and economic impact. So I'll highlight at this point that we've focused on domestic impacts of the transition. So there remains a significant opportunity beyond the work that we've done here in the numbers that we present for the UK to secure jobs, export skills and expertise and technologies out with the kind of domestic UK lens that we're looking at just now. Our assumption in this modelling is that all of domestic production goes in to meet domestic demand in our scenarios, but obviously there's the great kind of potential opportunity in things like export of green hydrogen, and also for import of carbon dioxide for carbon sequestration in our abundant reservoirs, saline and spent oil and gas. So I'll briefly just touch on each of the 3 scenarios here, and then I have a more detailed slide just to go through each of them in detail and the kind of key economic outputs. So we've named our 3 different scenarios: emerging, progressive, and transformational. Emerging is really our kind of baseline scenario. It's, if you like, a traditional approach to the transition with a high reliance on gas and CCS, so very similar to that visual I've just showed you from the further ambition scenario. Obviously, a lot of CCS required to offset emissions, and we've, in this scenario, got a limited expansion of offshore wind. So it's almost a what-if scenario. What if we don't quite get to that 75 gigawatt target that the CCC have laid us out with? So we've got 60 gigawatts of offshore wind in this scenario. Our progressive scenario is more ambitious. We've got 100 gigawatts of offshore wind in that, displacing imported gas for power generation and also hydrogen production. That obviously has implications in terms of securing UK jobs, as we're importing less and relying on our own resources, and also an increased economic benefit as a result. Transformational is our most ambitious scenario in terms of UK renewables deployment, 150 gigawatts of offshore wind. So that supports a fully decarbonised electricity sector with a very high proportion of renewables in there, as well as opening up the opportunity for green hydrogen at scale. So you don't have that competition between electricity for the grid and electricity for green hydrogen when you have such significant quantities. And I think when we started off, it's worth saying that these values were maybe overly, well, almost seen as overly ambitious, but more and more recently, we're seeing a lot of information coming out from the likes of Renewable UK, and I wouldn't be surprised if we see something from the Committee on Climate Change next week in their updated scenarios with some similar sort of numbers in there. So this is our kind of at a glance slide, and there's a lot of information in this, and conscious of my remaining time, I'm going to try and get through as much of it as possible before I leave you with just some closing points to note. So this slide summarizes all of our modeled scenarios and compares them with today's baseline. So in purple on the left-hand side, you've got today's energy sector. The offshore sector supports approximately 140,000 direct and indirect jobs. That's across primarily oil and gas, but increasingly made up of a small portion of renewables, which is obviously expanding. We've calculated an estimated total economic impact of around about 40 billion per annum to the UK economy through a combination of things like taxation, jobs, and spend in the economy associated with the activity. Our current total import dependency is around about the 40% mark, which I highlighted earlier. And that's a trend that's really been increasing year on year since the early 2000s, albeit 2020 is likely to show a slight blip in the record, as it will globally for energy demand and other things. By 2050, all of our scenarios predict an increase in economic impact. So you'll see that along that kind of top line of boxes on the slide. This is primarily due to the increase in demand. However, you'll note that this doesn't necessarily correspond to an increase in employment across each of the scenarios. So for example, in our emerging scenario, we predict that natural decline of oil and gas jobs combined with a high import reliance and low kind of to medium renewable activity will result in a net job loss in 2050. Oil and gas traditionally supports quite a high proportion of jobs compared with things like offshore wind. If you want to use an analogy of an oil and gas platform versus an offshore wind farm, you know, it takes far less kind of offshore workers to manage and maintain that activity than it does for an oil and gas platform. So yeah, the key to, I guess, the difference in the job numbers is really that reliance on imports. It's that import dependency. So when you've got a high reliance on gas imports in the scenarios like emerging, you end up having this lower job output and also economic impact, because essentially you're losing that section of potential. In our progressive scenario, it looks to reduce that reliance on the imports by increasing the offshore wind to 100 gigawatts. So a number that some of you might have seen in the likes of Renewable UK's recent publications. This results in the reduced reliance on the imports, and obviously you start securing more of that domestic energy production and the domestic jobs associated with that going into our requirement. Transformational, that's really a really forward-thinking scenario, an offshore sector dominated by offshore renewables, 150 gigawatts of fixed and floating wind. And in this scenario, as I mentioned before, the level of wind that you've got enables your kind of decarbonisation of the electricity sector, but also supports green hydrogen at scale without having that competitive factor between, do you put your power from offshore wind into the grid, or do you use it for green hydrogen? Clearly, all of these scenarios have an associated cost. You can see down in the bottom kind of box there that there's an associated cost per year of spend, ranging from 6.5 billion annual spend in emerging to 13.4 billion in transformational. However, the end results are clear to see in terms of supporting the domestic jobs and the economic impact that's associated with that. Conscious of time, I'll briefly touch on the technology piece at the bottom. A lot of this came from our recent work with Wood Mackenzie. We published a report called Closing the Gap, which some of you might have seen, the Tech20 from Malcolm Forbes Cable on this. So we've really just highlighted some of the opportunities in terms of technologies that will enable these scenarios and enable the affordable transition to net zero. And there's a few figures there. Conscious of time, I just want to nip onto my last slide because I want to leave you with a few key messages. 20 minutes is a difficult amount of time to try and get across this amount of information. But I really like this, this little kind of quote or passage from the report. The size of the challenge is surpassed only by the potential rewards of success. And I think that really sums up the work that we've done in the IEV. So I just want to leave you with a few key messages. One, by investing in technology to create an integrated net zero North Sea, the UK can be a supplier rather than a buyer of affordable clean energy solutions. And that really comes down to that gas import dependency. The country can retain its competitive position in energy skills and capability, growing jobs over the next 3 decades to up to 230,000 jobs, offsetting expected job losses in oil and gas. But we need to act now. And the transition ultimately will require big investment. So up to 416 billion of investments needed over the next 30 years rather. But the rewards are potentially staggering, up to 125 billion per year to the UK economy. And with that, I think I'm just about out of time. So I'll hand back to Stephen and welcome any questions in the Q&A session. Thank you.
Thank you very much, Jason. 20 minutes is a severe test of your skills to get across the key points that you wanted to highlight from the report. And I would encourage everyone to go to the report and digest it. So we have some questions. David Wilkinson has asked a great question. Would green hydrogen be primarily for electricity generation when wind and solar are low? Surely better to use offshore electricity for domestic heating and transport rather than hydrogen. That's a fantastic question from David. It's a question that we see in the commentators making a point that the commentators make all the time. So Jason, just give us your thoughts and perspective on that, please.
Yeah, I think from the scenario work we've done, there's definitely a point where you can say, offshore wind, it makes sense to obviously use it for electricity for the grid up to a certain point. And I think we see that in emerging, where we don't have a lot of green hydrogen in that scenario at all. But once you get up into the kind of 100 gigawatt type area, that's where you start to see, well, there's going to be excess capacity. And obviously, offshore wind is variable. The wind doesn't blow all the time, and sometimes it blows too much and you have to shut down. So yes, it's never going to be as simplistic as the way that we presented it here, but what we're trying to do is present kind of like a high level visualization of this, I guess. We've taken some statutory increases in onshore renewables. And yes, that also plays a part to the green hydrogen story. I guess offshore, we've got things like infrastructure, got the hydrogen backbone, potentially the concept for supplying Europe with green hydrogen for export. So yeah, it's never going to be as simplistic as what we've outlined here. However, I think what we're trying to say is, when you're more ambitious with offshore renewables, you can offset job losses and also provide the opportunity for green hydrogen over the next, say, 10, 20 years to reach cost parity. And it's never going to be as simplistic as a clear switch over.
Okay, thanks, Jason. David, I wonder if you have a follow-up point or comment on Jason's answer. I'm going to let you give you control of the mic now. So if you wish to speak, please do so.
Not really, no. I'm happy with the answer, and yeah, thank you.
Okay, super. Good. Well, one thing that occurred to me while we're waiting for more questions to come in is we published the report. What happens now? What are we expecting the report to achieve for us, Jason?
Yeah, absolutely. Well, already we've had a huge amount of interest in the report, and really one aspect of this, I really see it's providing a bit of a baseline for a lot of more specific targeted work. So for example, we're in conversations the other day about zero hydrogen shipping. The universities have been speaking to us about running programs, specifically looking at providing a little bit more detail on this baseline of information that we've provided here in the IAB. So I think what we've done successfully is bring together various different sectors with an aligned view of the opportunity. But now we really want to use this as a springboard for conversations with the likes of governments, investors, and obviously there's some key technology aspects from an OGTC perspective that we can get after to enable this. We've kind of highlighted where the prize is and what the opportunity is, which I think is going to be key in some of the major investment decisions that are going to come in the next few years.
Super, thanks, Jason. I'd like to kind of ask one of our colleagues, Luca Corradi, to come in, because he was involved in the process of helping develop the report too. Luca, you've listened to Jason's brave attempt to summarize much of the report in 20 minutes. Is there anything that you would like to comment on? I'm going to give you the mic now.
Okay, now it's a mammoth challenge summarizing the report in 20 minutes, but I think what the report highlights very nicely is the complementarity and the synergic effect of the various technologies that make up this integrated energy vision. So I think we should move away from, okay, blue hydrogen is better than green, or electrification is better than hydrogen. None of these technology on their own is a silver bullet. Apologize for my ring bell. And none of this technology will solve the challenge of net zero on its own. And all of these technology have room for improvement in the space of cost reduction and technology improvement. So it is really a matter of acting on different fronts. And there will be different time of maturation. So no doubt green hydrogen is a long-term solution for hydrogen. Blue hydrogen is the short and mid-term that will also unlock carbon capture, decarbonizing other sectors. So it is a complex system. And I think this report articulates very well how there are different variables and different scenarios in which this can develop. And the three scenarios all bring to net zero. You know, they're not alternative ending, and just a different way of getting there. And we probably have to adjust those scenarios in the next year, 2 years, 3 years, depending on the technology development that we are able to achieve. One thing I would like to add is also the complementarity of this report with another report that we published in September this year, which is Closing the Gap. And that is a report on technology for net zero. So the technology that are in this report here, and showing where are the main areas of focus we should focus on, in terms of developing technology that can reduce the cost and make that more affordable. Because in the end, we need to get to an affordable net zero, and that's our purpose now.
Thanks very much, Luca. We have another question from one of our participants, from Alison Isherwood. Alison, rather than read it out, I'm going to give you the mic, and hopefully you'll be comfortable enough to ask the question yourself. I'm going to give you the mic now.
Okay, thanks, Stephen. No worries. It was just a question on local content for some of your job estimates. I know that's something for offshore wind. We have, you know, in oil and gas, we're quite good. We have quite high levels of local content in what we do. And in offshore wind, historically, we've struggled, and there's plans to try and increase the percentage of local content. So I'm just wondering what assumptions you've made for the different scenarios.
Yeah, that's a great question. Thank you for asking. I should have covered that actually in the earlier slides. So the model, it varies across the different kind of sectors, but on a whole, it's roughly around about the 60%. So that's one of the key elements of this, you know, to get anywhere near the numbers that we're suggesting in terms of jobs and economic impact, you have to secure the UK content. So it has to be, you know, UK supply chain coming in for around about 60%. I think oil and gas, our numbers are slightly higher, and offshore wind, I think we've gone for 60% on that one specifically. I think over a broad kind of section of all of the sectors. It's roughly about 60 to 65% we've assumed. The model we do have, you can vary those assumptions, and it does dramatically increase and decrease the output depending on that. But we only present the one output in the report, which is based on roughly 60%. So it's a challenge in itself, and there's a key message there as well, that we have to secure the content from UK.
Okay, thanks.
Super. Alison, any kind of follow-up comment or question on that answer?
Not really. I guess that's aligned with the offshore wind sector deal, I think it's called, that the UK government are trying to aim towards, and it's a little it's higher than we have now. It's just a real challenge, I guess. It's 60% doesn't sound that high, but I understand all the limitations on that.
Yeah, absolutely. And there have been some quite high-profile recent tenders and things not going to UK companies in the press. So yeah, it is a challenge. And with the government's increased target of 40 gigawatts by 2030, I think it's going to be quite challenging to get to that level, 60% for those numbers. So then when we increase them again by 2050 up to say 100 gigawatts plus, it magnifies the opportunity, but also the challenge. So we're hoping that some of the outputs in terms of potential jobs, and you're putting a number on the jobs and putting a number on the economic output, it puts it into perspective for governments, regulators, policymakers, whatever, in terms of the requirement and the necessity to secure the work in the UK.
No, that's great. And I guess marine energy is, I know this is another question, I'm asking another question now, but marine energy is just seen as too nascent, too expensive to be included in here.
So we do have a very small proportion of other marine energy, which is made up of a combination of wave and tidal. It's not significant enough to have its own kind of column in the sector, but yes, generally the costs are extremely high for it. But we do see niche applications for things like tidal stream, wave, and potentially tidal barrage as well. But it only makes up a small proportion of the energy mix in our scenarios at the moment. For the reasons that you just stated.
Okay, thank you.
Super, thanks, Alison. I'm very curious as well. I know that we have on the line, we have Willie Reid from the University of Strathclyde. So I'd like to bring him into the conversation as well. Willie, get prepared. Hopefully you've got a comment to make. But the reason why I'm raising that is because this is a really huge challenge for our society to actually achieve net zero by 2050. When you look at the pathways that have been given, it's achievable. The investment profile is high, but it's not out with scope of what we've done in the North Sea previously to develop our resources. So the role of the university sector to help us develop innovation and develop new technologies is crucial to this effort as well. And that's why I'm asking Willie, if you're there. Let me see if I can find you, Willie. I'll unmute you. If you've got anything to add or comment that you would like to chip in, that would be really interesting to hear. So Willie, the mic's yours.
Can you hear me okay?
We can.
Okay. Anyway, I'm sorry, I was tied up a bit earlier this morning, and I was able to join around about 10 past 11. But I have read the outline of the report, and I'll give you some sort of general comments. The first thing is I'd like to give, first of all, an advertisement. Professor Sir Jim MacDonald, who's our principal, is giving a lecture at Aberdeen University. It's the R.V. Jones Annual Lecture, invitational, and that's taking place next the 10th of December at 6 o'clock. It's quite a prestigious event. I would ask you all to tune in to Jim. He advises both UK government, and he's also on Boris Johnson's technology and advisory team. He's got some very interesting ideas as to where all this goes, and he's basically asking for a call to arms to take the energy transition to the next level. So please tune in next Thursday. That's an Aberdeen University event, although he's the principal of Strathclyde.
So Willie, has he read our report then?
I don't know. I haven't talked to him.
It might be useful.
With him about 10 days ago, but I don't know the answer to that at all, Stephen. But anyway, just some general comments. We're going through a very interesting dynamic here, and I've participated in various events through in Singapore. I attended by invitation the FT event this week. And when I look at all of this, I find the European dynamic quite significant in this area. And one of the things that I find interesting is certain dynamics like taking solar and the entrepreneurs who some really big entrepreneurs in the European scene, who really are looking at big bucks investments and the banks, etc. And my question to Luca, to yourself, and to Jason is really, how do we actually engage relative to all these major activities that are occurring in Europe and Germany? Many of these are leading the way in a number of these areas. How do we engage with the European scene to make things really valuable in the UK?
That's a tremendous question. I mean, maybe a wee bit out with the scope of the report, but Jason, I know that Luca is doing a tremendous amount of work on the European engagement side. Do you mind if I bring Luca back in to talk about that? Luca, do you want to comment?
Yeah, yes, and thank you for that. Yeah, absolutely. So we have established a relationship and collaborations with the like of TNO. We're discussing with SINTEF and other organizations around the North Sea, but even beyond that. The European scene is actually very interesting because of the Green Deal and a number of other initiatives, the hydrogen backbone, for example. So we have projects and relationship and engagement with that. Clearly, a lot will depend on what's happening in the next few hours or few days on the Brexit negotiation and the deal or no deal. That will give a clarity. I don't think it will change dramatically, but the collaboration will keep going. But it is important to understand in which form it can happen. Definitely, it requires a wider consortium with the European organization to work and to achieve, to access funding or initiative or connected with the European funding and initiatives, as I said. So that's one area. Another point I wanted to make, though, Stephen, if I can, is probably linked to the international element of the competitiveness and to what Alison said before on the local content, because we need to remember that the technology of today in all these scenarios is likely to be different from the technology of tomorrow. And so there is an element of local content in developing and deploying technology of today in both wind and hydrogen and CCS as well. But a key important factor is developing the technology of tomorrow. That's where there is an opportunity to establish a competitive advantage or an export potential advantage. So if we develop in the UK the technology that will make hydrogen, blue and green, more affordable, that will make wind, floating wind more affordable, and the integration with the oil and gas, which is also cleaner and more affordable, then there's a big potential to export that to other basins instead of importing technology to do it. And so while we should, we welcome and encourage the investment from governments into deployment projects, which is a great way to start learning by doing and by deploying, we also need to focus and invest in the technology innovation, which is also what we are doing in collaboration with this European organization.
Thanks, Luca, and thanks, Willie. Unfortunately, we only have a few moments left. It's a very tight schedule, Tech20. It's a great discipline to keep it to the point. I would like to just wrap up by saying thank you to everyone who asked a question. Thank you to everyone who took the time to come and listen to this snapshot of the report. I would also encourage you to dive deeper into this report with us. We're holding an Insight 60 next Wednesday, the 9th of December at 11 o'clock in the morning. you're extremely welcome to join us for quite a more in-depth analysis of what's in the report, and I'm sure there'll be tons of fantastic questioning and debate arising from that presentation. Jason, the plan is for you to do it, and we look forward to hearing from you next week. But to everyone that came today, fantastic to have you with us, and we're pleased that you took the time to investigate this very important report with us. Jason, it just leaves me to say thank you to you and to the team behind pulling the Tech20 together. Thanks very much, guys. Please do come back next year. We'll be publishing details of the Tech20 program for 2021 in the new year, and we hope to have an exciting lineup of technology presentations and interesting speakers to present their ideas. So have a happy Christmas, everyone. Have a fantastic new year, and look forward to seeing you in 2021. Thanks very much for coming. Bye.
Bye.